In the fifth question we have in an AP, if pth term is 1 by q and qth term is 1 by p, prove that the sum of first pq terms is half times pq plus 1, where p is not equal to q. Okay, prove that. Once again we are talking about a question which says prove that. So let's write first whatever is given. Pth term is 1 by q. If it is an AP, A plus D, A plus 2D, comma dot 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 is the AP. Let this is the AP. Okay, and it is given that pth term is 1 by q. AP, which is the pth term, is 1 by q. It is also given that qth term, which is AQ, is equal to 1 by p. Prove that the sum of first PQ terms. To prove sum of first PQ terms, SPQ, is equal to 1 by 2 times PQ plus 1. This is what we are interested in, right? Okay, and how will we prove this? For SPQ, we know that this PQ is the number of terms. We just need A and common difference. And for finding A and common difference, we need two conditions. There are two conditions present over here. We can use those two conditions to get A and D, and therefore the sum. So let's start with the proof from here. AP is equal to 1 upon Q, and what does that tell me? AP will be A plus P minus 1 D, which is equal to 1 by Q. Let's call this equation 1. Let's call this equation 1. This is equation 1. What else? You have another thing over here, AQ. AQ is equal to 1 upon P. That tells me A plus Q minus 1 D will be equal to 1 upon P. Is that okay? Yes. What else? Can you solve these two equations 1 and 2 to get the values of A and D? Yes, that's very much possible. And how will we do that? So we are given two equations and two unknowns. We can easily find the values of A and D by simple elimination, right? We can subtract to give, let's say, the value of D easily, and we can correspondingly, once we get D, we can find A easily, right? Okay, so I would like to subtract, yes, but then I would like to make a small modification first. These two equations are there, I can easily subtract them, but can I also do one thing? Can I also write these two equations in this particular form? Let's multiply with this Q. This is AQ plus PQ minus Q times D, which is equal to 1. What about this? This is AP plus PQ minus P times D is equal to 1. And now let's subtract these two. Now let's subtract these two, and subtracting these two gives me A times Q minus P plus PQ minus D is coming out common, PQ minus Q minus PQ plus P times D is equal to 0 over here. Is that okay? Yes. So PQ gets cancelled. This is P minus Q. This is Q minus P. I can take out a Q minus P common. This will be A and this will be minus D is equal to 0. And since P is not equal to Q, this is non-zero. The product of two numbers is 0, two real numbers is 0. This is non-zero. Therefore, A minus D will be 0, or that tells me that A will be equal to D. That's the first thing that you observe, that A will be equal to D. That's what you observe. Okay. Once you have noted that A equals D, can you easily use 1 or 2? Let's say use equation 1. That gives me A plus P minus 1 times D. D can be replaced with A again. This is 1 upon Q. Okay. You can take out A common. P minus 1 plus 1 is P. So AP is equal to 1 upon Q, or A will be equal to 1 upon PQ. And D is also equal to A. Therefore, both are 1 upon PQ. And now the next target. For the proof, from the point of view of proof, we need SPQ. So therefore, SPQ is equal to PQ by 2, 2A plus PQ minus 1 times D. Okay, and what will this give me? Let's take a look at this. A and D both are 1 upon PQ. So this is, let's say, PQ upon 2. A and D can come out common. This will be 1 upon PQ. And in the bracket, you will get 2 plus PQ minus 1. What is that? PQ plus 2 minus 1 will be plus 1 over here. This PQ gets cancelled with this, and what you get is SPQ is equal to 1 upon 2. In the bracket, you have PQ plus 1 as seen over here. And is this what we wanted to prove? Let's take a look at that. Is this what we wanted to prove? Yes, this is what we wanted to prove. That's the complete proof of this question, as you can see over here, using these steps, right?